Hello, this is Raf Alvarado. Welcome to Exploratory Text Analytics. In this video, we're going to continue our conversation about cultural analytics and the concepts of culture and talk about the connection between those ideas and the methods of unsupervised learning and pattern discovery. Unsupervised methods are one of two main areas or branches of machine learning, but they are much more than just a set of techniques for clustering. They are also associated with the broader practice of knowledge discovery. I would argue that they're more accurately about pattern discovery, and that the discovery of patterns is central to the study of culture as I've just defined it. So here's a diagram that shows the general, classical breakdown typology of machine learning. And I really like it because unlike other similar typologies, it goes into greater detail about what the unsupervised side of things is about. So we know about supervised learning. This is, if your data are continuous numeric data, then you would use regression. This is your classic linear models type stuff from statistics. Or if it's categorical, you would use classification methods, and down, underneath that node of this graph is the whole world of methods that very often gets equated with data science and machine learning. And here we have things like support vector machines, logistic regression, neural networks, and so forth. But let's put that to one side because we're focused more on unsupervised. So unsupervised methods are those which, as I've argued, and many have, and I'll show you a quote in a second, is focused on knowledge discovery and looking at patterns. And typically you often see only clustering listed under unsupervised methods. Techniques for grouping together the points in some kind of vector space using either bottom-up or top-down methods, hierarchical or k-means clustering. But in addition to that, there are at least two other approaches out there. One is what we could call dimension reduction, and we're going to go into that, the use of things like principal component analysis to make sense of unsupervised data. And there's also association rules, which I would link with graph theoretic approaches to working with data. We're not going to go into those as much. We're pretty much going to focus on clustering and dimension reduction type methods. Here's a quote from Kevin Murphy's book, Machine Learning, A Probabilistic Perspective, which I think is a great introductory text to machine learning. Its only drawback, perhaps, is that it is wedded to MATLAB as a programming language, which is a fine programming language, but I think a lot of people have moved on to Python and R, and it would be nice to have a companion version of this text in those languages. And here he defines unsupervised learning as having a goal to discover interesting structure in the data. And he also goes so far as to say that unsupervised learning is oftentimes called, or sometimes called, knowledge discovery. And this is exactly what we're talking about in this course. This is why we're interested in unsupervised learning, because we are definitely interested in looking at interesting structures. So among the particular unsupervised methods we're going to use in this course, I'll list four. This is a little bit of an apples and oranges mixture of categories here. Clustering, for example, is a specific area of unsupervised method that we just talked about, whereas sentiment analysis is a broad sort of charge to figure things out in a particular space, which may use unsupervised methods or other methods. But nevertheless, we're going to treat these all under the category of unsupervised methods. So we have clustering. We're going to look at principal component analysis. We're going to look at k-means and hierarchical clustering. We're going to look at topic modeling. Pretty much going to focus on latent Dirichlet allocation, but non-negative matrix factorization, NMF, and latent semantic indexing, LSI, we're going to glance at as well. Word embedding, which is a way of exploring the meanings of words as evidence through a corpus of text, primarily through word2vec, but there are other methods as well. And then there's sentiment analysis, which is the attempt to discover the sentimental valence of a text and the variation of sentiment over time or across the structure of a text using various methods. And here I could just point to two classical dictionary-based methods, and something called Vader, which we're going to look at when we explore this. I'll point out that sentiment analysis is part of a broader field of content analysis that goes back pretty far, actually to the 1950s.